Yeah, it's recording now.
All right, so thanks so much. Sir, also the proof slides which you uploaded, I texted you also, they are blank for us. So if you could re-upload them.
Really?
Yes, sir.
Okay. All right. So I'll do that. I'll do that.
Yes, sir. So the first doubt was, uh, what, what do we precisely mean by the degree of freedom?
Degree of freedom. Okay. So, degrees of freedom means that when you're working with a data set and you are calculating sample statistics, then for the same data set, you calculate more than one or many sample statistics. You need to see the data from many angles. So you need the mean, you need the standard deviation, variance. Both are the same things, and um any other statistic, for example, the slope coefficient or the intercept. Uh, these are the things you want to calculate for the same data set, right? So whenever you are calculating these things for the same data set, basically uh, you are losing the amount of freedom you have. So you would want your variables or your values to vary. So you can allow them to vary freely, and or you can place some restrictions, right? So if you are saying that the mean is this much and the standard deviation is this much, then beta 2 is this much, and for beta 2, for example, you need to know the standard deviation, or let us say z. So for z you need to know the mean and the standard deviation. So you have put two restrictions on the calculation of Z, a third statistic, right? So you have actually lost 2 degrees of freedom. So the more things or statistics you would want to calculate or you are calculating for a given data set, for a given sample, the more pressure you are putting on the data, right? So that lesser degrees of freedom you have. So you will have less freedom if you calculate more statistics for the given data set. That's the intuitive understanding of degrees of freedom. Mechanically, computationally, you can just subtract the number of restrictions you have placed on the data from the number of observations that you have, right? For example, if you have placed two restrictions, your degrees of freedom would be n minus 2. So instead of using n, you would use n minus 2 for calculating any statistics that you want to calculate, right?
Yes, sir, got it. Uh, and sir, my second question is, what do you mean by the blue region which you were referring to in your PPTs? Like one was the green region, which was the p-value region, which was under the tails, and then there was this under the bell shape, if I can say.
Yeah.
So, what is that blue region indicating?
Uh, there is the area in the tails, and there is area in the body. So the green region was the tails, right? If I'm not wrong.
Yes, sir.
And in the body it was blue color, right?
Yes, sir.
All right. So uh, basically, in normal distribution or t distribution, standard normal distribution and the t distribution, we place our statistic at the center, right? So and there is variation around that center, right? So our null hypothesis, it depends on, I mean, it is used in hypothesis testing. Uh, then we have confidence interval approach and we have level of significance, or let us say, what can we say? Uh, Level of significance approach, right? Um, so in this level of significance approach, we reject the null hypothesis when our test statistic is far away in the tail, right? So just to check that whether our test statistic is far from the center, that means it is in down in the tail, we we specify that how much area in the tail are we willing to accept. So that is our alpha level of significance. 5% area is okay for us, suppose. Then if our statistics in the tails, we reach that green area, which is the uh, uh, rejection region. Green area is the rejection region because we reject the null hypothesis, right? Because we are far from the null, right? Because null is in the center. For example, 0, beta 2. Beta 2 equals to 0 is our null, right? So 0 is in the center. And if our statistic falls in the tails, and so far in the tails that it reaches the green area, which is the p-value, and it is less than 0.05, that's why it's in the tails, then we will reject the hypothesis that it is 0 because it is far from 0, right? So the green area is the rejection region. Rejection of what? Rejection of null hypothesis. And the blue area is the acceptance region, right? So if your statistic falls in the blue area, then you would say that we cannot reject the null hypothesis. So blue area is nothing but the acceptance region, and the green area was nothing but the rejection region. And we demarcated green and blue areas using level of significance alpha, 5%, it may be 10%, depends how much green area do you want, right?
All right, so I think so this partly answers my next question as well. What do we mean by level of significance? It's basically how much we want our acceptance level to be.
Yes, 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 exactly. It is completely upon ourselves that how much alpha we want to work with. If you want, you can work with an alpha of 10%, or if you want, you can work with an alpha of 5% or 1%. So, how strict you want to be, how you don't want to reject the null easily, right? Suppose you want to be absolutely sure if you want to reject the null. Otherwise, you would not want to reject the null. If this is the case, then you would set it to 1%. So it will be more difficult for you to reject null because 1% area is going to be very, very far into the tails and it will be difficult to reach there, right? So if you want to be very strict in rejecting the null, then you can move yourself to the tails and you can make your alpha to 1%. If you want to be rather uh, uh, liberal and you would want to reject the null easily, suppose, so you can set your alpha to 10%. In that case it will be easier for you to reject the null, right? But it's not so simple, right? I mean, what I just explained is right, uh, but if you are increasing your alpha, there is a price that you pay. And then for explaining that, I have to go more deeper into statistics, right? Into type 1, type 2 errors. And then I have to explain few more things, right? Which I have not explained. So um, what I want you to understand is that it's not that simple, that it's not so simple a statement that I made that, okay, you can increase alpha, then you can make it, sorry, you can decrease your alpha to 1%, then you would be more confident and your results would be more accurate. No, it's not like that, right? But yes, you can set your alpha to 5%, 1%, 10%. These are the generally three accepted areas in the tails that statisticians or researchers work with. So it depends completely upon you. There is no rule to decide this. It's your choice.
All right, so basically, alpha, if our alpha is more, we are easily accepting our null hypothesis. So our results will be
Easily
a little
rejecting.
more,
Rejecting. You will be
yeah,
easily
yeah, sorry,
rejecting the null.
easily rejecting our null hypothesis.
Yeah.
So our results would be more precise in a way we can say, like they'll be more accurate or they'll be more closer to the mean.
They will be less accurate. I mean, I should not say this in these clear words that accuracy and non precision or not doesn't completely depend on this. There are other factors also. But yes, if you have set it, if you have set your alpha to 10%, it means you will be more readily rejecting the null easily. It will be easy for you to reject the null, right?
Yes, so it's easier to reject the null. That's why our data may be more accurate or less accurate.
No, no, no.
Like that's the confusion.
No, no, it's not. Your data is accurate or not. It's not that much, black and white. But the only thing that you can say is if it is 10%, if it is high, like 10%, then you will be easily rejecting the null. If you want to reject your null more easily, then you can set it to 10%. If you want to be a bit strict, then you can set it to 1% so that you will be rejecting your null.
And sir, who decides? Like the researcher decides
Yes.
whether I want my research to be more strict or liberal. But how do I come to that conclusion? Like as a researcher, what should be my parameter to evaluate whether I should be strict or liberal? Like I
Okay.
can't be biased, right?
That's what I just said. That it is completely upon you, and there is no rule to decide it. There is no formula or
No,
a
no, sir.
mapping.
What I mean is, for example, you are conducting a research and I am conducting a research. You take 5%, I take 10%. Our results will differ. And my research may contradict yours, and my research, since it was favoring favoring a particular it was about
No,
acceptance of Keynes theory,
it's
say
not like
suppose.
that. No, no, no. It's not like that. For example, if you have rejected the null, then you would not say that okay, I have rejected the null. You would say I have rejected the null at 10%. So the reader will understand that you have rejected the null at 10% level of significance, right? So the reader,
Okay.
you will not say that I have rejected the null and that's all. You would have to mention I have rejected the null at 10%, or I have rejected the null at 5%, or I have rejected the null at 1%, right? So there is no confusion for the readers of there is no difference. For example, somebody else has rejected the null at 5%, he will mention it in the research. So it is very clear in that sense.
All right, so got it. Thank you so much.
Yeah. All right, what about other students? Please ask questions. Whatever question you have in your mind today, you can clarify all those doubts. Okay, in the meantime, let me check what happened with that proof. Yeah, it is blank.